Hello, everyone. There are some sections already talk about the Metaverse. So I think that everyone are quite expecting the Metaverse. Metaverse will enrich the way of communication in cyber social media and other cyber activity. So you can put on your VR, AR device, and then you could chat, play, do exercise, shopping with your friends in the 3D world. But I believe it still needs years to make the technology mature. So today, I want to talk about the digital twin. It's a metaverse of product development, which is adopted in the industry. Okay, so Dassault System rolled out our first software called COMPUTEX in 1981. It's a purely 3D CAD solution in the beginning. At the time, the mainstream the CAD solution are only 2D. So 3D is at the heart of the Dassault System. So we do believe the virtual world will improve and extend the real world. So to achieve a more sustainable future is possible by leveraging the virtual world. In real life, there's no rehearsal, but in virtual world, you can simulate and evaluate the impact of your product before you produce it. So the virtual world will help you think differently. So in Dassault, actually, we advocate virtual twin more than digital twin. So we have a 3D experiment platform to support the virtual twin. So there are 4 core technologies to differentiate between virtual twin and the digital twin. The first is digital continuity. So nowadays, in companies, you will have many IT solutions for different disciplines. For example, you have PM solution to handle your project, BOM, and CAD data. You have SPDM to manage your simulation and testing. You have CAPP to manage your manufacturing process. And then you might have another solution to handle your sales and marketing. So Dassault, we engineer all our applications on the same platform. So we share the same data, so we link all the process. So it means you don't need to export or import the different data format between different IT solutions. So you don't need a bridge to integrate different IT silos. So the second is data-driven. Traditionally, you have different files. You have the Word, Excel, you have the CAD, you have the CAE data, you have manufacturing data, and all your knowledge and content are still in file. So in able to access the knowledge, you needed that application to open the file. So on the platform, we use metadata and data stream and system model. So it could be easily for you to share and link and analyze and help you make a decision quickly. So the third is model-based. So we use 3D data as our backbone. So from design, simulation, manufacturing, you can use the 3D data to go through your life cycle. So you don't need to rely on 2D drawing. Everything is based on 3D. And the fourth one is virtual and reality. So through our simulation technology, actually you can simulate your product behavior and performance with multi-physics and multi-scale. And then during the process, anytime, you can wear your AR, VR to experience your product performance. So in our 3D experience platform, they are just apps. So you have apps for you to manage your project, for you to manage your bond, for you to have a social design. It's like your internal Facebook, but you are sharing with your design idea with your colleague. You have 3D modeling app, so you can design from material to a product, to a car, to a city. You can just make your 3D model. And then on the same platform, you could have your simulation and the manufacturing app. So you can work on your 3D data and continue to perform your multi-field simulation like structure, fluid, electromagnetic simulation. And then you can have your process planning for your digital plan. And then on the same platform, we have information intelligence app. So you can analyze and help you make a decision quickly. So among them, as long as they are 3D, you can just put on your the AR, VR device instantly and experience your product with your team and even with your customer. So what is a virtual twin? A virtual twin is not just a 3D representation of your product. It could include the control system, firmware, software, everything necessary needed to make your product work. When your design is complete, product is produced, so then you can connect your complete the virtual twin to your physical product. So in reverse, you can collect your data from your physical system and then analyze, optimize, improve your production. So in the reverse, it's possible for you to drive your physical system from your virtual twin. So it's a two-way communication between the physical product and the virtual twin. During your design process, maybe some of your subsystem prototyping is ready. For example, your steering wheel is ready. You just put on your ECU, your control unit, and then you can connect it to your virtual twin. So your hardware can link with your digital twin and send a signal to your the virtual twin to have a simulation. So you see, you have the complete definition of your virtual car. So you are able to validate the simulate all the innovation design. For example, with this electrical vehicle, you might have a new design to turn your car around at a point. So you can validate all the control system and mechanism if you can work as your design. So it's a virtual twin, so you can analyze all the performance of all your component, any component. You don't need to put a physical sensor on a real car. So you can simulate all the driving condition. For example, you will have a exciting innovation for you to able to have a street parking just by side drive your car into the parking lot. So you want to make sure it work. You want to make sure it work with your hardware, software, everything. So this is a virtual twin of a system. So how to work with VR, AR? First, we can use the VR for design. So they start sketching their idea with VR, with immersive experience. Or even you can work with existing 3D model, and then you can explore more of your design idea and option. So, and then you could improve your product. So with VR, you can sketch, and you can even sketch on your 3D model. It looks like you are sketching on your clay model. So you just based on your existing service, and then just sketch it, and then you could get your new idea. So this is we are provide the VR to explore your digital virtual twin. So you can also use the VR to modify your design instantly inside your virtual twin. Okay, so then we move to the detailed design. So there are many design activities. You will design your mechanism and your metal part, composite part. And anytime you want to review it, you just put on your VR device. You don't need it to export your 3D data to the VR animation software. In there, you need to redefine everything. You just on the same platform, just click on an app. So now you can review your product in rendering or in your mechanical design view. You can explore your portfolio with different combination, with different idea, and discuss. So if you have some new idea, you can just take off your the VR and then modify in your system and then come back to review. So the VR device is used for daily design and daily work. Even you can work with your customer to propose your solution. So for the Metaverse, you needed a human. So in our budget twin, the human should be more precise. It's not a gaming on the character. Actually, it's economic on engineering. So you can define your gender, age, your body shape. There are hundreds of parameters to make you to set the dimension at as the same as your body. When the set is ready, and then you are ready to go into the virtual world of your product. So you just wear the VR with a controller, with checker. So you go into your virtual design, and then you can review it, and then make sure the designs meet your the mission. So what about the management? If I can manage something with 3D, yes. When you are have project management, issue management, actually, as long as there's a 3D there, you can work with 3D. For example, now you want to initiate a new issue, so you can define where is the issue located. Like a Google Map, now you navigate your 3D product. So and in the same 3D, you will same environment you should define to describe your issue, and then you are assigned your colleague to perform this task and define when it will be done, and you can check the status anytime, what has been done, what is pending, what is needed to follow. So this is the way we manage your product in our 3D experience platform. So let's talk about simulation. Can you tell which one is really physical car crash testing and which one is simulated by simulation? Okay, so in Dassault, we are combine our technology of simulation and realistic rendering. So why this is the traditional way? You have a mesh model and you simulate your product. So we provide a better view to review your result. You can review more information than you have a high-speed camera with a physical test. So you can easily remove the skin part, sheet metal part, and take a look at the structure you want to investigate. And you could, with realistic rendering, to understand how your the structure been deformed. You can be in any point of view to understand your design after a crash. So in the design phase, car company needed to have an internal test. So you need the physical markup. You know, it's costly and time-consuming. And internal test has a limited space. So it could only show the performance, not potential. So we can, our fluid simulation solution can simulate your car running on an open road with traffic turbulence. So it could create more effects which cannot be seen in wind tunnel. So you cannot make a right decision of your design if you cannot see the right effect. So with full simulation with real world condition, we can reveal the more problem and help you to make a better decision within the virtual world. Okay, so then how to work with VR? If you got the result, and then you can put on your VR instantly, and in the virtual world, you can put a different model in the same space, and then you can use VR to review the result, no matter it's a fluid simulation or structure simulation. So you can feel how the wind flows through your product, and then help you to understand how to improve your product. So so it help you instant response for you to go to the next investigation. Okay, then let's now talk about manufacturing. So on the same platform, you just click on your manufacturing app. You don't need to install another solution. So you can start offline programming and simulation on the virtual world. And then before you put your program to the real production line, actually you could connect the whole system with your PLC I/O signal and have virtual commission to virtually make sure all the device and the machine could work as your design. So when you validate all the manufacturing process perfectly, and then your virtual train could be connected again to your real production line, and at the time you could use your the virtual world to monitor the operation at your production line, physical line. Okay. So let's talk about more about we have the process planning on our assembly line. So now you can put the human here. You could simulate all the operation assembly process in each station, what the tool they need, what the material they need, how to operate, and the line balance. Which station is not good enough is over the cycle time, and then you need to rearrange them to another station. And then you have ergonomic simulation of human. How could that operate the assembly process properly, safely? So all this is simulated done in the virtual world and can improve and make you ramp up sooner in your production. So after you define the, your process, now you need to have material flow simulation to make sure the throughput is as you want. So in the production line, you could have a human, robot, and any automatic machine. Then you could check the iteration rate of each device and the total throughput and where is the bottleneck, and then improve it. And so after you have the design anytime, you can use VR to view the operation on your production line. So you might have several proposals. You send it to your review team or even communicate with your customer. And then you could make a better communication and make a right decision of your plan of your manufacturing. Okay, and then I want to show you a testimony of Honda North America. They talk about their digital twin of manufacturing.
Our vision is to realize the full potential of the virtual methods to simulate the Gemba. Now, the Gemba is a word we use inside of Honda that means reality or at the spot. We want the simulation, the virtual world, to look exactly like our manufacturing situation for what we're doing. Now, we have a strategy from the model to the layout program all the way up to simulation. This is what we want to accomplish. Again, to keep it in the context of the plant. What you see in the bottom center area is the virtual build context. That's what I showed you before. That's where we are. The images going up and to the right are what we've created and are continuing to enhance. So we had to start with building the plant. As I mentioned, we only had 2D data. We don't have any 3D data history where we can rely on. So we had to build the basic foundation of the plant, to model that with a great precision. Beyond that, now we have to do conveyor simulation. This is really critical for us to understand how the product moves through the plant in its various build-up states. So we work very closely with Dassault in order to understand how to model it, how to program it so that we can get the logic to work correctly as well. This is the actual instrument panel line, and now connect that to the modeling. This is where we're really focusing to improve the accuracy and make sure that it matches reality. So we've got the kinematics of the modeling in there for the fixturing that the associates have to move up and down to do the assembly work. We've got the conveyance systems. You can look at the local areas, and then finally at the entire work area in context, and you can see all the logistics containers around that where we can expand that further into the future. Now going to the main line, we're able to simulate what is it going to look like, and this is great. As much as Honda likes to move models from plant to plant, it's really an easy way for us to verify, can we put this model in that plant? It's reflecting the actual manufacturing plant condition. This was critical in what we wanted to accomplish. And of course, we're laying the groundwork as we continue to enhance and develop this area for future activities. You can imagine the logistics and the carts running around inside the plant to simulate that and find the optimum delivery routes, for example. So in summary, we've accomplished a lot. but specifically, realize the full potential of the virtual methods to simulate the Gemba. We've got to understand that actual situation. And Dassault Systems, Honda's achieving our simulate the Gemba vision using the 3DX tools. Thank you for your time and attention.
So if you don't have so many videos like Honda, and you don't have a 3D plan, how do you do? Actually, it's an easier way for you to build your virtual plan quickly. We could support the 3D scan data. You just scan your existing plan, and you got the point cloud. So then you just import it into our platform, and then you could start to have your journey of digital twin. So you can just split on the point cloud as product, and then link to on the IoT of your plan. So you can use it for facility management or your IoT dashboard, and to quickly have a virtual plan. So, and then this first step. Now you want to improve your production line with the new facility area section by section. So now you have a virtual plan there, so you can simulate to put on your new equipment, your new robot, put on your process, and put on your material, and then simulate on the way of production, then before you really move to the production. So you may have different idea, you may have different way of the production line. So through our manufacturing app, you can quickly design, validate your manufacturing process before you move into your production. So as long as your 3D plan is ready, it's not just for the process planning, you can connect it to your MES system or MOM system. In Dassault, we have appraisal. And then you can link with the information in your shop floor. So for example, they are red light, you can remotely know, okay, in the station, they have a shortage of material. So you need to send someone to deliver the right the material properly. So this the budget train can extend to connect with your the shop floor operation. So let's talk about the certification. You know, we are talking about autonomous driving. Do you have any idea how many kilometers of text is necessary to make sure safety of the autonomous driving? It's 18 billion kilometers. So it means you need a lot of prototyping. You need a lot of people. It's truly time-consuming and very, very costly. So with our budget train of our testing environment, actually you can connect the environment with your driver simulator, with your digital twin of your product, and then simulate. You can set up the environment, the different road condition, different weather, is raining, like today, or is snowing. If there are suddenly some passenger across the road, there are some incident with animal. Anyway, you can set up on many different the road condition and simulate simultaneously, which will reduce a lot of your physical testing. Even physical testing is necessary. Okay, so then you are moved into the sell your product. So with VR, you don't need to set up a huge car showroom to put all the portfolio of your car for your customer to make decision. Actually, just put on VR for them to explore different features and then make a decision soon. So we work with our customer Airbus in 1920 to have a 5-year project to define digital design, manufacturing, and service. So we could also work with Airbus. So we will build up a digital twin of production system, digital twin of system industrialization and the service. And then last point I want to talk about a little about the digital twin of human. So Dassault Systèmes in 2014, we work with researcher, industry, clinic, and regulator FDA. We signed a 5 years to develop the worldwide first medical label on human heart model. This model includes structural and electrical stimuli on the fluid simulation. And scientists are able to invest on the first time how their medical device will be implanted into a living heart, and how it will work in the 3D. It reveals more detail than animal and the human tests. So this project is quite successful. So in 2019, we signed another 5-year project to continue improve the digital twin for human. We start to build the model for brain, for other body parts. So yeah, as long as you have 3D, you can just wear VR to explore your human body with details. So Dassault Systèmes, starting from a 3D software, we provide a digital twin of product design, and now we extend to this twin of human to help us make a more sustainable world. Thank you for your listening.